कर दिया ज्वाइन कर दिया अटेंड सेल
Good evening, everyone. Am I audible?
अरे तुम्ही अजून भी कन्फ्यूज नका हो अकॅडमिक ऑडिट
वो कैमरा थोड़ा नीचे क्लियर नहीं।
Good evening, everyone. Am I audible to you?
Yes, sir, you are audible.
Thank you, ma'am, for your confirmation. I would like to request to all the participants kindly join the session as our chief resource person, Professor S. Suresh sir, has been joined up in this Zoom faculty development program.
Hello, my slide is audible, which are visible to all of you. Hello,
Wait, sir.
my slide is visible to all of you.
No, sir, not now, right now.
Why it is not sharing? Not sharing, no. That's why I'm telling sharing is not happening.
So slide is not visible.
That's why. That's why. Wait. I'm just doing. There is something.
सर मुझे व्हाट्सएप कर दो यहाँ से कर देंगे।
हाँ एक मिनट
So shall we start? Today's the number of participants is so much low. Can we wait for them? So once again, good evening to all of you. Myself, Desh Deepak Srivastava from Sri Satya Sai University of Technology and Medical Sciences, Sehore. I am an assistant professor in aeronautical engineering department in this university. On the behalf of our university, I would like to thanks to all the participants, all the delegates, and all the research person has been joined up in this faculty development program. Also, I would like to thanks to our Honorable Vice Chancellor, Sir Dr. Mukesh Tiwari, sir. Under his guidance, under his leadership, under his continuous motivation to all of us, we are conducting this virtual faculty development program in our organization in School of Engineering. Also, I would like to thanks to our coordinator, Mr. Dr. Sachin Baraskar sir, who has been coordinating this faculty development program in our organization. Also, I would like to thanks to co-coordinator of this program, Mr. Manoj Kumar Ganwane sir. He has been contributing a lot for making this virtual faculty development program as a successful grand event. Also, we are thankful to our research director, Dr. Mohit Gangwar sir, for his continuously support. Also, I would like to present my thanks to Dean School of Engineering, Dr. Rajan Singh Kuswa sir, for his continuously monitoring this faculty development program for its grand success, as we have successfully completed 4 days of this faculty development program. Also, I would like to thanks our chief guider of this faculty development program, Dr. Santosh Kumar Rai sir, who has been behind the curtain, has been originated or organizing this FDP program in our university. For today's session, I also want to thanks to all the participants. It gives us great pleasure to have you all with us today. Despite your busy schedule, your presence make this program very meaningful and successful. We are especially grateful to our esteemed guest as a resource person, Dr. S. Suresh sir, for accepting our uh, invitation, and we are very thankful to our professor resource person, Dr. S. Suresh sir, for sharing their valuable time and knowledge with us for today's session. About S. Suresh sir, I would like to brief some important highlight about S. Suresh sir. He has been a professor in a faculty and head of department in chemical engineering department in MANIT, Maulana Azad National Institute of Technology, Bhopal. He has been received PhD in chemical engineering from Indian Institute of Technology, Roorkee. Professor Suresh was the recipient of postdoctoral fellow award by IUSSTF, Government of India at that time. He was associated at the City University of the New York, CUNY in USA. He was also the recipient of Visiting Faculty and Researcher Award by Government of India. During this award, he has deputed to the Asian Institute of Technology, Thailand, and also the International Center for Material Science, Bengaluru. One more thing, one important thing I want to highlight about S. Suresh sir, that he has a world's top 2% most cited scientist by Stanford University and Elsevier survey assessment. He has a more than 16 years of experience for teaching research from Manit Bhopal, also Pondicherry University and IIT Kanpur, ICMS, JNCASR, Bengaluru. AIT Thailand, CUNY USA. He has been invited for industrial and technical skills certificate training on urea stripping, fermentation technology, process safety and environment, air, water and solid, fundamental and management, waste to energy, OSHO laboratory, safety standard. These are the some research area he has been worked us for. He has supervised 9 PhD students, 68 MTech, MSc, MDS student, and 280 BTech project students, along with the supervisor and the co-supervisor. So this is basically the brief introduction about Suresh. He has just so much intelligent and it's so much has a lot of experience about the research and the knowledge. I think so this session must be very beneficial and useful to all the participants. So I would like to request to all the participants, don't miss this opportunity. You will get a lot of experience, lot of knowledge and lot of insight from our respected resource person, Dr. S. Suresh sir. So I would like to request to all the participants, kindly join this session and gain whatever you are gaining from our resource person, Dr. S. Suresh sir, through this faculty development program. Once again, I welcome to you, sir, in our university for joining our proposal invitation on a short period of time, and now you are going to share us your valuable experience to our all the participant and sharing insight with this university. Over to you, sir.
Thank you, Yugandhar Tyagis, for a wonderful intro. Thank you so much. I think my uh, my things are audible to you, all of you
Yes, sir. Yes, sir.
Yes,
participants.
sir.
Yeah,
Yes,
very
sir.
good
Yes, sir.
evening to all of you. I think I hope I will not take your time, dinner
Yes,
time.
sir. Yes, sir.
Okay, before dinner, I will try to complete it. Maybe those who are taking the dinner of 7:30 or something below that. Okay, anyway, nice intro, man, Tyagi.
Thank you,
And
sir.
thanks, first of all, I would like to thankful to the organizer for a wonderful topic of this AICT FDP, Green Hydrogen and Future of Renewable Energy System. Like organizing, like a coordinator Manoj and other team person, as well as the administration of Sri Satya Sai University of Technology and Medical Science, CORS. Okay, so all of you, very warm and good evening to all of you. Right, I think maybe I am seeing that there is a participants are number of participants are increasing time to time, so maybe I can make them more vibes and more peak on them. So okay, be follow me, okay, right, all the participants. Okay, good evening to all of you. So my only request is that please put off your mobile mic Mike, and just listen. If you have any question, please put that in the message box and end of the my slide presentation. So you can, you are most welcome to ask the many questions. No problem, right? Now, formally, I just starting my presentations. Now, today I'm going to tell about the simple or interesting technology, day-to-day life, like current situations. We required some of the technology for energy conversion as well as the energy storage. Now, I'm taking taking the topic is that fuel cell, one of the technology that is called fuel cell, and what is the application over this. Okay, I hope that last 3 4 days you are more listening and engaging with the energy production or energy storage application and etc. Now I hope that the fuel cell one, which has the hottest technology and latest one, it's needy for day-to-day life, day-to-day industrial revolutions, 5.0. Okay, right. So just next, please, next. Yeah, this is my presentation agendas. If you talk about that, I'm going to speak on this flow only. Like you talk about fuel cell introductions, function, type of fuel cell, and requirement of the fuel cells, and development in the fuel cell, and way forward. What we are going to get it from this 1.5 hours. Okay, right. Way forward. Next. See, before starting this fuel technology and applications, I would recall you for what is the Indian our national stand on clean energy. That means you talk about that fuel cell or fuel cell technology, it will come under the clean technology or clean energy. So, what national our Indian contest stands that when you talk about the Prime Minister Modi announced during the UN New York Climate Summit meeting, the Indian further commit to increase its renewable energy capacity to 450 gigawatts by 2030. That means what we are targeting, or what our nation is targeting, that we are keep on increasing the renewable energy source and capacity, and we are going to achieve in 2030 450 gigawatts. That means we are to work for the renewable energy for better conversion, get the clean energy. We required the specific technology which can prove that the clean technology or clean energy productions. Next. So before starting the actual the configuration functioning of this fuel cell, I would like to address few things about the what is the current status about the Indian energy consumption for the electricity generation. If you talk about the world scenario, you talk about this one, you see that here the nuclears and other renewable energy is 5%, and solid biomass and waste almost 23%. Petroleum is 23%. Of course, natural gas is 8% and coal is 41%. You see the right side. What are the specifically the Indian energy consumption for electricity generations? You talk about mainly on coal, 57%. And then when you talk about a gas, 9%. And then you talk about the biomass and other renewable energy, 12%. That means what we are, our national aim of the clean energy scheme or means promotion, that we need to enhance the biomass and other renewable energy, not only 12% to going to the higher side, so that we can produce the clean energy through the fuel cell technologies. Okay, that is what this slide shows. That next, please. So here specifically I taken the renewable energy source. When you talk about the natural gases, nuclear one side and coal is another side, and petroleum is one side. If you talk about renewable energy, like maximum the 6% in out of 6% of over, you talk about the it consists of biomass 47%, and hydroelectric, geothermal, wind, and solar. So these are all like a top. We can talk about the clean resource or clean renewable resource. Okay, which can be like we talk about that 50 to 20% of energy consumption is going to getting through the bioenergy by 2030. That is what our idea, national idea, this national is moving towards for to achieving this 15 to 20% of energy consumption. Next, please. Next, please. See, if we get energy resource, you talk about the energy resource. So, of course, as I told you that in the pictorial view, pie chart. See, normally when you talk about fossil fuel, so oil, coal, and gases. And when you talk about renewable sources, for example, sun, biomass, wind, and hydropower, this is well known. Okay, so how we are going to explore going to explore the renewable sources? Okay, why we are going to explore the renewable sources? Because the fossil fuel or sources still complying with the current need, their extraction and use, we have serious negative social and environmental impact. Why? What is the serious negative social impact is there? Environmental impact, because it can produce n number of greenhouse gases like a CO2, any other greenhouse gases. Okay, now we are going to target, or we are going to address that to control the serious negative social and environmental impact by applying the renewable sources. Say for example biomass, especially because in sun, wind, and hydropower it's well established. Now we are going to utilize the biomass or various biomass, and we are going to explore the clean energy fuel technologies. Okay, so request to all participants, please mute it. So whenever maybe we can ask the question, or maybe you drop the question in the message, okay, message section, so I can definitely answer it. So I think some background voice is coming, right? So if you look at the renewable sources or alternative for fossil fuel, of course, the renewable energy is abundant. It can be supplied greater than 3,000 times the worldwide energy consumption. That means what happened? There is a plenty of scope for renewable energy, which can overcome which can compensate for the fossil fuel sources. Biomass is a currently mostly used renewable energy source. Of course, it is contributing 9.8% of total primary energy supply. Okay, that means what I'm trying to say, that biomass is a plenty available and we need to explore. Okay, biomass means it consists of different biomass. Say for example, you talk about the like agriculture residue, you talk about the domestic waste, municipality waste, you talk about any other biomass like we talk about grass, or you talk about any other biomass which is coming under this one, right? And if we talk about the convert biomass as efficient and clean as possible, the most efficient conversion of biomass will be a reduce the amount of biomass required and energy accessibility is improved. That means what we are trying to compensate the source which we are getting from fossil fuel, and we are going to make a mix source, or maybe in the standalone source like a renewable energy source also. Therefore, You talk about modern energy in the form of electricity is the desirable form of energy, as access to the electricity is a key driver for social and economical development. That means we are going to develop the technology and we are going to explore the renewable energy source like a biomass, different biomass, and we are going to convert through the fuel technology like advanced technology, energy technology like a fuel cell, and therefore that should be a simple and cost effective technology is required. That means, for example, fuel technology is the one which can be simple and cost effective technology, and it will be highly efficient to convert the biomass into the modern energy developing countries, especially for about Indian context. We are talking about the energy content. Okay, so this is about the kind of things. Please, next slide, please. Next slide. Next slide. No, previous one. Sorry, previous one. So here we talk about the traditionally waste view as a just 1 second. Hello.
Yes, sir.
Yeah. Sorry for Anna. There is one here. There is a some kind of voice is breaked. So now it is audible, no? Right.
Yes, sir. Yes, sir.
Yeah, exactly. So traditionally, if you talk about the waste, the is a main problem. Of course, I told you that the biomass we can call as the like a different waste we can call as the biomass. Until otherwise, there should be a proper utilization. So then we can talk about a traditional waste. But the waste contains significant quantities of the energy, and we could harness this close to where the waste is generated and it's converted into the useful form. It could provide both a distributed source of electricity and contributed to the solving the global problem of waste. Of course, the today high energy requirement for the conventional sewage treatment system. I'm just giving the one of the example like a waste. I told you that a different type of waste we can call as a biomass. Some of the waste like a liquid form or maybe a solid form, and one of the liquid form is the sewage, whatever the sewage sludge which is coming, that we can explore proper way to get the clean energy, say for example in biogas or maybe in that in the form of some different energy convert like a methane and other source also energy. So these are all a good idea. And microbial fuel cell, of course I am going to discuss in future slide, means coming slide. And microbial fuel cell, that is the one which is now more attractive way, and it is going to directly produce the electricity from the utilization of different liquid waste like a wastewater, and opening the door to the futures in which the waste treatment plant not only with the power themselves but it sell excess electricity. So I am going to cover it, okay, in later slide. Next, please. So here I just keep one simple way of fuel cell introduction. Like you see that how it will work. Say for example, you start from say for example, air is coming, hydrogen fuels. Say for example, and then you talk about the air and hydrogen fuels, and then you talk about cathode and anode. Okay, so just giving that this is called proton means we can say that proton exchange membrane. You talk about PEM is the proton exchange membrane. You go for this one, what is going to produce here? The electrochemical reaction between hydrogen and oxygen, and we are producing electricity, and we are getting the waste heat and water vapors, and which is going to collect, and we can go for the recycling, or we can integrate this waste heat into the different form. Okay, so when you want to make a waste heat plus water vapor, we can combinedly we can make into the cycle, and then we can use for the industrial purpose as a raw material. Maybe we can make it into the boiler for feeding of the input for the boiler for the waste heat. And ultimately what you are getting, we are going to get it exchange of, there is a reaction, electrochemical reaction between the hydrogen and oxygen, and will produce the electricities, and directly we are using the electricity to the directly the plant and users. Okay, the input is hydrogen, methanol. Sometimes we can use hydrogen, okay, for the input, and sometimes we can use for the methanol also as a source of to make a fuel cell work properly, okay, or functionally properly. This is the as simple as flow how the fuel cell will means the pictorial view of fuel cells, especially for a proton exchange membrane. Next. See here the fuel cell pictorial view. What are all application? If you look at, say, first one, when you talk about that hydrogen, like we have a fuel cell vehicles, or you talk about the drone. Okay, whatever the drone is there, it is just like making. And then if you talk about the generators, okay, hydrogen generator, maybe fuel cell, you can keep it in the this side, hydrogen flow. This one anode and cathode, and we talk about. Here also we are carrying the transport the like I can say that for the purpose of transporting the different vehicles like track lorries and other things. Okay, heavy vehicle things also we can use the fuel cell as the mode of transportations. And you see that these are all like a current scenario what fuel cells currently people are using here. That is a very like interesting technology nowadays to fulfill the energy and clean energy demand. Okay, next please. So here also some of the application, when you talk about applications, so we talk about the drone and air mobility. Some people are working on the fuel cell. By help of the fuel cells, they can operate the drones. And when you talk about off-road vehicle, like we talk about the hydrogen power, okay, hydrogen to powers, and we talk about the kind of area which can be required the energy. So we can use for this one. And when you're talking about the stationary microgrid, you talk about a stationary microgrid. When you talk about these the people are nowadays using the microgrid, and microgrid can be going to the electricity transformations. And then here the mobility, like we talk about the your train and bus and other things. As you know that the fuel cell has a vital role for the transportation sector. And locomotive, of course, the train which you are getting the locomotive train and different trains, goods, and etc. We can go also by using the fuel cell technologies. Okay, that is what this slide shows. That next please. Right, so this is the exactly the fuel cell arrangement in the car. For what is the purpose? To make a fuel cell to drive the say for example, when you talk about hydrogen fuel cell, say for example you are going for the car which is going to in future, definitely there is innovation is going on, development is going on. So a hydrogen based engine, say for example hydrogen tank, we talk about hydrogen tank, that is called distribute the hydrogen to the anode to the fuel cell system. Once here electron are skipped from the hydrogen by and platinum catalyst. So here, so we are hydrogen tank which consists of platinum catalysis, and it can be you can say that transfer the electrons from the stripped from the hydrogens. And second one is the air intake. You talk about air intake, that is the supply of oxygens, especially air, to the cathode side of the fuel cell system, which later combines with the now positively charged hydrogen to the produce water as a byproduct. Okay, so you see that the hydrogen will be a positive charge of hydrogen to produce the water as a byproduct. Then when you go for the third section, that is called fuel cell system, will provide the right environmental for the hydrogen to form with the oxygen to create the electricity and water. Then it is generate the electricity that flow to the electric motors. That means just like a, it is giving the electrochemical reaction is taking place from hydrogen to the oxygen, and we can produce the electricity and water. Water is the byproduct. Then generate the electricity, flow to the electrical motor. It will go to the motor, and then the electricity will be produced. Then the battery supply extra power. That means you can suppose, say for example, the hydrogen production is or electricity is more for this electric motor. So we can keep the battery backup, and then we can store that energy, and so for whenever wherever need, okay, the extra power, and store energy from the regenerative brakings. Suppose, say for example, you required the we can say that automatic brake or automatic clutch and gear, so we required extra energy. So for the battery can be supply the extra, we can take the extra energy from the battery and we can move further. So the last one is the electric motor, that is called power and turn the wheel. That means ultimately, so we are just moving the wheel, then automatically your car will be moving fastly or moving with respect to these 4 5 mechanisms, right? So I think this is the interesting things, and many of the motor vehicle automobile companies are already started. So they are going to very soon, like already most of some of the countries are already started the hydrogen based fuel cell for running the car and other things. So very soon, or maybe little bit after sequencing the proper policy of our national policy. So I think this hydrogen fuel cell based car will be exposed in with due course of time at our national. Okay, next please. So here, the fuel cell arrangement, when you talk about fuel cell arrangement in the bus, okay, so if you talk about fuel cell arrangement in the bus, okay, you see that the configurations, and the configuration, if you talk about the power density, and then efficient and flexible control and advantage. You talk about that one, the basically the bus, you go for the main engine, and then you talk about the engine can be piston out and making the power density. When you talk about power density and the current density, it is just like a proportionally varies, okay, with respect to the pressures. What are the pressures? When you talk about the pressures, the pressure we are building from through the fuel cells, that means energy we are getting this one. You see here, when you talk about the configurations, when you talk about the one side, like a 4 into 75 kilowatts, like say for example, it is accelerations. When you talk about the kind of making this one, and 300 kilowatts fuel cell, and fuel cells making into the kind of the 40% higher than the normal. And when you talk about efficient, 53 percentage, like when you talk about you go for a fuel cells, it's a simple like then flexible control. When you talk about, yes, of course it has the flexible control. And when you talk about the advantage long, like we can talk about the long range, high payload, and reduce the cost. Of course, this had the good efficiency, making into the proper way of controlling the this we can say that the bus and other activities. So it's a good efficient one. Next, please. So here that mobility and transport locomotive also, here this we can say that Sony Path project and Balakot, we can talk about fuel cell is moved for that high density plus fuel cell. And like we talk about the shall do launch this year, maybe most probably they are planning to make it into the this year only. So this is some pictorial things which they are showed in this one. Next, please. Now we are fuel cell recent development improvement attributes. Okay, so you talk about the fuel cell recent development, like talk about the enhanced performance, the power density like a 5.4 the kilowatts per liters, and then we talk about the 3.1 earlier, whatever we have the we talk about the proton exchange membrane. So now due to the beauty like more activity of catalysis, different multiple level of catalysis are there, and it has the more activating the particular reactions, electrochemical reactions. So obviously there is a enhanced performance. Okay, if you talk about enhanced performance over the PEM, proton exchange membrane, and there will be a catalysis. We are keeping this one. So of course the proton exchange membrane is getting the charge and exchange of charge, and it's accelerating the charge by keeping this catalysis both the side, and then there is a chance of enhancing the performance like a 5.4 to the 3 point instead of 3.1. So that means what happened, we talk about the weight reductions, stabilities, and environmental corrosiveness. That one of the important target is that when you talk about the construction of fuel cell, it is made up of the stainless steel, or we talk about the different the metals, okay, metal oxides or other things. But when you talk about the corrosions, of course there will be a chance. Then when you are going into the catalysis, when you are keeping this one, so it can be enhance the performance and can reduce the I can say that corrosiveness. So that is ultimate. We need to push on this one, right? That is what this slide shows. That next, please. Now again, these the six primary components which we can talk about the fuel cell recent development. You talk about the catalysis. Of course, I said discussed last slide, and catalysis are very important and very important role for the enhancing the performance of the fuel cell. And there is a different range of catalysis are available, and researcher are developed many of the catalysis. It function is multi-level functions. And then ionoser, so people are working on this one, and fantastic ionoser is required to boost the exchange of particles, exchange of charges, okay, between one side to that. And another one is a proton exchange membrane. Of course, it required some membranes that consist of exchange the protons from one side to another side. So we require a special membrane the material. So that is also one of the important components for enhancing the fuel cell. And then when you talk about gas diffusion layer, you talk about a gas diffusion layer. So diffusion layer is very important, because in which that most of the gas like oxygens will went out to other side, and maximum high electricity can be produced, and there will be a chance of water formation is less. So that's why the gas diffusion layer is very important. And binder, of course, the binder is one which can accelerate the diffusion layer. The diffusion layer which can be make a the binders and making a proper ways. Okay, the frame, of course, when you are going for fuel cell stack, different stack, that means one cell, then two cell. So the more than two cell we can call as a stack. The stack required the basic structure, and then in the basic structure we have 2-3 fuel cell can be arranged in the horizontal way and rectangle way. So that's why we require the frame. Frame is very important, because sometimes frame also will include the performance, or it will deal with the performance. That's why we require the 6 primary components in which we can fuel cell can be developed, and then it can be optimized through these 6 primary components. Okay, next. So if talk about that, what are all like a recent development, like a change in the material. Say for example, I told you that there is a material is required. That material, what are all latest recent development is there. When you talk about the silicon, you go for into the silicon like a basic fuel cell technology, and you talk about the enhanced performance like a durability and then cost efficiency. Okay, so you talk about the cost efficiency and durabilities. If you talk about silicon-based fuel cell technology, like it is a one which can be changing your performance, and then component level like silicon-based bipolar lightweight. See, as I told you that we required less weight or compact manner, so that the micro fuel cells can be keep more and more stack, and it cannot be taken more space for any industrial purpose, or maybe a lab purpose, laboratory this construction or configuration. So we require the lower weight of the fuel cell. Then you talk about the durable nature and mechanical stability, and then chemical stability. Of course, the chemical stability and the mechanical stability is very important. You talk about the mechanical stabilities. Okay, so we require the frame of your fuel cell, which should have mechanical proper stabilities. And of course, when you talk about PEM, we are using the proton exchange membrane. That proton exchange membrane should have the viable and the more potential for the mechanical strength and chemical stability. Of course, there should not be the much more chemical stability in which the maximum run of fuel cell can means run of your experimental can be done through the fuel cell, and it should not have any kind of corrosive effect and even other effect chemical stable like stable controlling means, or we can say instability of any performance. So then ability of the withstand high temperature and corrosive environmentals. So now, what is the important point of silicon-based fuel cell? You talk about the silicon-based allows for the creating of microscale flow channel on the plate surface. Combine these attribute directly enhance the power density, durability, and performance of flow cell compared to the non-silicon-based fuel cell. So, as you know that silicon-based fuel cell, the silicon has a tendency it can create the microscale flow channel. That means what I am trying to say that micro scale flow channel is nothing but in this one particular flow, whatever you are giving the inlet or input. Okay, so in the silicon has the multiple level of channelized or maybe a porous manner. So it has the own nature of flow the make the flow into the micro scale level, and then it can be different channelized. So it what is the main advantage of to make a multiple flow channelize or micro channelize? So it has the several advantage. One is the it automatically power density and enhance, durability can be good, and performance will be comparatively when you talk about non-silicons, that will be much higher than this one. Next, please. So here another this one is simple, like when talk about that perfluorinated sulfuric acid membrane, the high proton conductivity and chemical stability. These are like advancement of PEM. So we can use that perfluorinate, okay, sulfonic acids membrane we can use instead of proton exchange membrane. So in order to get the more proton conductivity, high proton conductivity, and chemical stability is more in these particular things. And even of course Nafion also we can that DuPont, that company, DuPont company, they are commercially their trading name is called Nefron. Nefion's is the most common use for that this particular fuel cell, and ionomers for the catalyst layer of ME methyl ethylene. We can say that the these alkaline membranes it required the operating of fuel cell at high temperature, say for example above 100 degrees centigrade, and lower relative humidities, say for example 60 to 70% to improve the reaction kinetics and simplify cooling and humidification subsystems. Okay, so if you look at kind of systems, okay, you talk about the right side, this is completely the picture review of that PFSA, how it is functioning. When you talk about fuel cell and the gas diffusion layer, catalyst, anode, the reactions, hydrogen is split into the hydrogen plus, and then you talk about the electrons, which main electrons are getting into the kind of things, and polymer electrode membranes. We talk about polymer electrode membranes, and catalysis mainly a cathode. That what are the hydrogen which is getting into the catalysis, that will be making into the cathode, and the cathode will be emit the electron, then it will be mixed with or combined with the oxygen, it will form the water. That means mainly what we are talking about, that one is the hydrogen evaluation, or mainly talk about this water. Okay, then for finally that charge in hydrogen plus electron will form the electricities, and then we are going into the kind of kind of mechanism which can be get into this one. This is the something like a PFASA fuel cells. Next, please. So here, of course, we talk about that PEM. Still, PEM people are working on it, and it is maybe much lower platinum loading compared to the illustrated illustrations. For example, platinum loading of the first generation, of course, the Toyota, this company. I'm just giving you some literatures like we talk about the PEMs. This Toyota they used in 2017 first commercial PEM fuel cell vehicle, and it has the power density. You can check it. And then they used for potassium hydroxide as a solution for the electrolytic. Of course, the electrolytic solution is required to exchange the protons or maybe electrons from one side to another side. And especially platinum replace some conventional acidic and alkaline solution with the advanced perfluoric sulfuric acid membrane. That means Nephron, that which is the DuPont company. They commercially they developed this one. And improvement in membrane electrodes. When you talk about membrane electrode assemblies, and then it is mainly membrane electrode assemblies and then structures and related manufacturing process. Power density, of course, as I told you that when you are keep on increasing that 6 components, primary components, which I told earlier discussed. Okay, so if you develop the membrane electrode assembly structure, so it will be a good which can be enhance your performance. Okay, so next please. So here, how the methanol, suppose for example, instead of hydrogen, we are using the methanol, say methanol or CO2. Now, interesting thing is that nowadays, instead of hydrogen, so we can use the carbon dioxide or methanol, okay, as a fuel to the running the fuel cell. And direct methanol fuel is the important electrochemical energy conversion device, which transform chemical energy of the liquid methanol into the electricity directly without any intermediate process or moving part that make into the efficient source of power. That means we can use the methanol as a source and CO2 use as a source for input to generate the fuel cell, or getting the running the fuel cell, and in which there is a electron and hydrogen will be generated, evaluated, and water mole vapor all will be come out. If the anode and cathode, in front of that, there is a membrane electrolyte. Maybe the electrolyte may be a potassium, like a potassium, whatever this potassium hydroxide, or maybe we can talk about the any kind of alkaline mediums we can use as a electrolytic solutions. Okay, next please. So here, the next generation like Toyota or BMWs are already launched the iX5 hydrogen. We can talk about the pilot flight. So fleet. We talk about the Toyota, which is currently being tested worldwide, targeting 2028. So this is the next generation's motive power products. When we talk about these fuel cell, that is called fuel cell stack. I told you that the stack is the consist of more than 2 fuel cell, so we can make it into the greater height or size, because we can increase the surface area and we can increase the volume of the fuel cell, in which we can produce the more electricities. You see that as per this particular next gen power modules, which is like we talk about the brand name of Height Cell engaged with India. So they developed the Gen 5 PM fuel cell. It has the vital potential or significance like 40% of lower volume, 30% of lower weight, and 50% of fewer components. And it can be operated lifetime, so without any interfering the difficulties. And then it can be significant cost and reductions at the volume level. So I think this is one of the good innovations on the fuel cell stack as such, and it is targeted in 2028 as first. Next, please. So here again, I'm just giving you that how this now this anion exchange fuel membrane fuel cell, that is called MFC. That is a kind of fuel cell which can be exchange the anions and membrane to separate the anode and cathode compartment. It is a promising, of course, it is a mix, like a hybrid of proton exchange membrane. We are coupling the specific anode anion exchange membranes into the proton exchange membranes with unique platinum based catalysis. How we are doing this one? We are just fitting into the PEM platinum based catalysis, and then we talk about several advantages. What is the main advantage? To coupling the particular platinum based catalysis into the PEM, that is called AEMFC. That advantage is that cost can be used for the non-platinum group metal oxide catalysis. Obviously, when you go for the platinum, non-platinum group, of course, less expensive. We can talk about the frames, And then you talk about performance, significantly improve in the performance and durability. Of course, the fuel cell required good durability in order to make more and more electrochemical reactions. That's why durability is very, very important, especially for your membrane material. And you talk about temperature increasing the operating temperature for this one and improve the cell performance, mainly to the enhanced electrochemical kinetics and ionic conductivity. That means what I'm trying to say, that if you are coupling with the anion exchange membrane into fuel cell, so what trying to basically, we are keeping the some of the electrocatalysis. That electrocatalysis will enhance the mechanism of electrochemical kinetics, in which we can boost the exchange of electron, exchange of ions, and there will be a conductivity will also speed up. That's why this specialty of AEMFC will have the I can say that important role for the fuel cells. Next, please. Here, so I want to say that, say for example, we discuss about the different fuel cell. So I'm going to point out here the proton exchange membrane, PEMFC, because of course this PEM proton exchange membrane, it's a well commercially available and commercially implemented also. And I'm going to discuss few things on this proton exchange membrane, because still people are finding the little bit low efficiency, and there is some issues related to the thermal stability. So I'm going to I'm going to show that how we can improve the thermal stability or thermal management in the fuel cell, especially for proton exchange membrane. So now, before that, I just see that how the proton exchange membrane, how it is operating currently. So you see that practically efficiency 60 percentage. Okay, overall, if we talk about this one, and this is the volumetric power density will be like much higher than as compared to the other fuel cell. So there is a two type of proton exchange membrane. One is the low temperature, high temperature. So low temperature, the power density will be the maximum, will get it 680. And when you talk about the high temperature, it will be like, I can talk about the power like a produce. Okay, up to there is some mistake is that, so it will be a vice versa. So you talk about definitely there will be a energy application such as vehicle and power generator. Okay, so now idea behind that this low temperature, high temperature, it's a high dynamic load response, enable the reduction of startup time and further reduce the surplus of the energy released through the startup process. It low operating temperature like 60 to 80 degrees centigrade and high current density at ambient temperature give the possibility of operating the device from the cold start. So what I'm trying to say, that when you are going into the high temperature proton exchange membrane, so in which some of the condition which have the low temperature circumstance in the some of the countries, so in which you required special attention of high temperature proton exchange membrane fuel cell, and in that case we required the particularly high temperature fuel cell. So that is what we are looking for that. Next, in some of the country. So here I'm just giving one idea how we can increase the thermal management or how we can increase the thermal stability. So we can include the nano fluid. What is the nano fluid? We will discuss it. Now the idea behind that why the proton exchange membrane, only the we are till now we are 60% efficiency are targeted or achieved. So we want to increase further. So there is a lot of consequence, because if you talk about stack, as I told you that there is a two more than two fuel cell in horizontal manner or vertical manner. It is a coupling. So there is a stack frame is consist of. Then we can call as the stack of fuel cell. So in that situations, when you are increasing the number of fuel cell in one stack, so there will be a chance of thermal stability and there will be a chance of the heat dissipations. Okay, so we need to control the heat transfer. Okay, in which your performance also will increase. So now right now there is a issues related to the proton exchange membrane for the dissipation of heat, and there is a improper management of heat transfer. So that's why I call as a thermal management. We required some nanofluid. The several researcher are using that nanofluid. I'm just giving you what is the advantage of this one. You look at that thermal management of the fuel cell. It's an important operating aspect. Then when you talk about improved through the advanced coolant, that means we required some coolants, okay, which can control the temperature, which can control the heat transfer in between your cooling the plate design, and then operating control system, okay, control optimization. To failure to manage the heat output could prove harmful effect to the device. That means what happened when you are not able to manage the heat transfer, or you are talking about the plate design in between your in between your electrodes. So definitely there will be a chance of decreasing your efficiency. So in order to avoid, so we need to some kind of coolant which can be a nanofluid, and that nanofluid can be a wonderful method to cool down or maintain the temperature and maintain the heat dissipations. That is what the excessive heat of the internal components of the fuel cell would lead to the overheating and thermal stress, okay, which is eventually result in the membrane dehydration. What is that? Whatever we are using the proton exchange membrane, and that proton exchange membrane, we you know that the costly of membrane is very more costlier than anything. So we need to like a return after 2-3 cycle. We need to regenerate it, or maybe we can return that stability as it is in the like a new one. So what we are trying to do, that we required to stabilize or to control the heat dissipation which is coming into the internal components. So that is what we required some of the coolant. That is we are talking about nanofluid. The nanofluids are now recently people are working on this, and several mechanism heat removal, of course, in the literature survey. Some of the coolant strategy is already there in the heat splitter. So people are using the spreader, the heat spreader. So the heat spreader is the like a kind of, it's a primary control the heat transfer, and but still the heat spreader is the temporary one. The spreader is temporary one which can be control the heat, but it is not that efficient as compared to the other like a nanofluid and other things. And one more thing is that a phase change cooling. That means phase change material which can cool down or maintain the cool. That is called phase change material, PCM. Okay, PCM is the phase change materials. And then liquid coolants. Okay, of course, the people nowadays using the liquid coolant like a water or other coolants. Okay, so that means what suggested that liquid coolant mechanisms are one of the most effective and statistic method used in the fuel cell heat removal. This method involved dissipation of heat by means of flowing liquid, water or coolants passing through the engine or radiators. So like a simple mechanism, only just like a radiator is there, the fin type radiator is there in the all cars, okay, to dissipate the, to maintain whatever the heat is coming in the from the engines. So it is just like a dissipating the heat. So similarly, though we required a fuel cell also, we required some of the dissipators or some kind of dissipator, so we can use as a nanofluid or spreaders. Okay, so that's why this slides is mean, and it's an interesting topic. Those who want to do the research, nanofluid for the advancing PEM fuel cell thermal management. Next, please. So like this slide also, mostly why we are going into this one, especially nanofluid. The nanofluid one, which has the nanoparticle. You talk about nanoparticle suspended in the base fluid, which is a particle size ranging between 1 and 100 nanometer. Okay, nanofluid are capable to increase the thermal conductivity of the base fluid due to the metallic nano size particle which are scattered within the base fluid that possess higher thermal conductivity and also increase the total surface area of the particles. That means what we are trying to projecting for the nanofluid, especially for controlling the dissipation of heat. Okay, so it has that dual role, mainly dual role. One is the controlling the increasing the total surface area of the particle, and we can go for the higher thermal stability, higher thermal conductivities. So in which the size is very important. You look at the size of the nanoparticle, nanofluid. It's a 1 to 200 nanometers. So it's very, very small, and it's a very quite easy to develop the nanofluid also. So it is the one we can use effectively for controlling the thermal. We can go for the thermal management in the fuel cells. Next, please. So here, some of the like literature researchers, they have developed the like a nanofluids. Okay, so they applying the nanotechnology. The thermal engineering is a novel concept, of course, novel concept. The nanofluid is the defined suspension of nanoparticle, especially the carbon nanotube. Okay, carbon nanotube, nanoparticles, metal or metal oxide. Okay, in the base fluids, and water and mixture of water, and ethylene glycol or oil. So this is the base fluid. We talk about water or mixture of water and ethylene glycol or oil. So in that we can dispose the nanoparticle like a CNT, carbon nanotube, metal or metal oxide. Okay, that is called nanofluid. Nanofluid is the two media or two components. One is the base, another one is the we can do nanofluid. So we can mix both the things. That is called, we talk about that. Combinedly we talk about the nanofluids. Okay, so what is the important thing is that it will increase the total surface area, and it will make a higher conductivity, thermal conductivity. So that's why I am mentioning here nanofluid possess some advantage like a high surface, specific surface area, high dispersion stability with the predominant Brownian's motion of the particle, reduce particle clocking as a compared with the conventional slurries, and promoting system miniaturizations. Okay, miniature means like what we talk about multi, or we can set the microflow channel. Microflow channel, it will increase the automatically, and adjustable properties including thermal conductivity and surface welding by varying the particle concentration. So we can vary the nanoparticle, and so that we can attain the surface wettability. As many of the participant know that, okay, how we can increase the surface wettability. Surface wettability is the one which required for the heat transfer. Okay, to improve the heat transfer. So the people are researchers are working on this heat, and surface wettability property is very important, especially those who want to do the research on nanofluid especially. Next, please. So here we have done, we have like in our group, we have also developed the phase change material like nanofluid, which makes into solid form. And then we have developed the phase change material, especially we taken the like different wastes. Okay, when you talk about microalgae, okay, and microalgae, which is very like costless, cost effective, and corn cob. Okay, so everywhere it is a corn cob is available, and pea shell. That means we talk about mutter, so just like a green pea. Pea shells we have taken from the market, vegetable market, and then we developed phase change material. Okay, so of course, the three material we have taken. So we found that microalgae has the highest surface area, 146.4. That means approximately 146 meters square per gram. The specific surface area, which is higher value as compared to the other, like whatever we taken corn cob and pea shell. And we have done the assessment, different characterization like XRD pattern, we have taken thermal conductivities. Okay, we found that especially microalgae, that dead microalgae based phase change material has a highest zero point 0.4 watts per meter Kelvin. Also heat flux as compared to the other two PCM. Like it is one of the important the properties. Like we talk about this, as I told you that nanofluid or a nano phase change material, whatever you prepare it, it should have high conductivity, thermal conductivity should be there. So we achieved that nearest 0.41 watts per meter Kelvin. So it is a wonderful, like it's a good highest value. You see here, this is the right side. This is how we prepare. We talk about that how we synthesize the phase change material by means of two-way process. So this is the procedure. And then when you talk about the methodology, when we are adapted for this one, this is the one which we talk in this way. So we got good results from this one. We can make into the commercial, like we are planning for making commercial, how this will be effectively work for reducing the heat dissipations, or maybe it can be enhance the heat transfer rate. Okay, so that that we are going to do in the we are doing this one. So this is the first phase of our study. We have performed, we got the good results. Okay, next please. Yeah, this is the global scenario. Like we talk about the green hydrogen, like when you talk about the fuel cells, so we should also discuss the green hydrogen productions, how it is effectively. You talk about the Australia, so you see that different project is going on, capacity descriptions and project name. These are like a very recent one, so you can note it also. Like Australia, we talk about capacities. Okay, you talk about descriptions, how this hydrogen can be produced, and the project name is they are giving this one. And you talk about the Egypt, Germany, Kazakhstan. Then you talk about the Oman. So these are all like I can say that the currently the project is running for the green hydrogen productions through electrolysis, and then that green hydrogen can be used for the running of fuel cells. Okay, running of, this is the input for the fuel cells. Next, please. So this is the Indian green hydrogen project is going on. So this is the, like we talk about that, as I told you that the first one. So our Indian contest, we target that 5 million metric ton per annum by 2030, aiming to become a global hub of for the productions, export and manufacturing with a focus on the renewable energy powered electrolysis. So you talk about national green hydrogen missions. Of course, it started like 5 year back and 5 6 year back, and now the main aim is that they are targeting for 2030s to 5 million metric ton for the green hydrogen production per annum by 2030. And renewable energy capacities, we talk about 125 gigawatts of renewable energy capacity by 2030 to power the green hydrogen productions. Then electrolysis capacity 15 gigawatts of electrolysis capacity of 2030. Budget, of course, they have allocation. The general government is allocated this much of billion of Indian money. So some of the key projects and initiatives, if you talk about NTPC, they have done the NTPCs and Oil Indian Limited's pilots plant. And when you talk about the Adani Green Energies, green hydrogen pilot project, and then green hydrogen fuel producer intensive. See, these are all like I want to show you that. Okay, so in our India also, our national also, they have started with the green hydrogen fuel cell and then electrolysis. Okay, day by day they are showing that we are remarkable. I can say that in this field, our India is going forward towards the achieving this all the target, which is I'm showing this one. Next, please. So right, so as I told you that the one of the fuel cell that is called microbial fuel cell. So that microbial fuel cell, it's like a one which can produce the electricity directly without any interference of any other mode, and by through the microbial activities. Okay, microbial activities. I will show that microbial activities one, which is fantastic. Microbial activities, maybe the municipal industrial organic waste, which contain naturally the microbial growth. So it is one of the good techniques for producing electricities, and through the bacterial or biochemical activities or biochemical reactions. Next. So here a simple the construction of the microbial fuel cell. Just you see that a substrate consists of anode and cathode. That means what we talk about, the anode consists of microbial growth. We talk about anaerobic chamber. And when you talk about cathode, that is the aerobic chamber. That is like when you talk about substrate, or substrate you can convert into CO2, and this electron is going to in the cathode chamber. And then electrons and plus your hydrogen is moving towards this barrier. That means electrolysis, means whatever the electrolytic solutions, and then we form the electricity directly. So this is only simple construction for microbial fuel cell. It's simple, like keeping the electrodes, both the electrode, there is a electrochemical reaction is taking place, and there is a involvement of the microbial activities, and there is a charge of the exchange of electrons from one side to another side. Next, please. So here the classification of the microbial fuel cell. So you talk about there is a different type of fuel cell, microbial fuel cell. It's depend on the principle and functionalization of your the fuel cells. Okay, so that is, you talk about the tubular, stacked, phototropic, heterotropics, and mixotropics, thermophilic, mesophilic. Okay, these are all like it depends on the bacteria, depends on the microbes, and different on the temperatures which can use for the activating the transport of the electrons from one electrode to another electrode. And then these are all the way we can improve the microbial fuel cells. So this is a classification of that one. Next. So here the working mechanism simple, that we talk about the electron proton release to the oxidation of feed by microbes. And then there is a electron mediator. Another one is a membrane. Membrane will give the proton transfer to the cathode, and the electron mediator, it's give the electron transfer to the anode, that is negative terminal. So negative terminals we take into this one, and they form the electricity, and then we go for into the waters. Next. So it is a basic biochemical reactions, or biochemical reaction or electrochemical reactions. When is the anode reactions, cathode reaction, when you talk about these hydrogens are splitting to form the CO2 plus hydrogens, and again the cathode reaction, hydrogen plus electron which is received from this one, and it will combine to the oxygens. Okay, of course the oxygen and then hydrogen is input. Okay, so the oxygens will combine with the hydrogen, will produce the water. So now cell reaction overall, when you talk about these cell reactions, will produce the carbon dioxide plus water. Of course, the hydrogen will be so here the idea began that the Gibbs free energy, the corresponding theoretical cell voltage should be a 1.09 volt. That means we required some of the voltage which has a higher side, and to overcome the 1.09 volts, then only your fuel cell, microbial fuel cell, or will be produce the electricity. Until otherwise you are not overcome this particular theoretical cell voltage, then your MFC or fuel cell will not run. Okay, that's why we required make a kind of the reactions or the microbial activity, and so we produce the more number of voltage in order to get the electricities. Next. So this is the thermodynamic principle. So it is also very quite easy. You can understand this one. So we use that Gibbs free energy. That is a we can talk about that. The Gibbs free energy is basically to make a how much the conditions are, how much energy is associated with the formation for the organic component in aqueous solution, and then we can calculate based on the Gibbs free energy to give the maximum work of the system, and it can be detected in terms of overall cell electromotive force, EMF. Okay, this is the equation, simple equation. We can see that also how we can find out the electromotive force. Okay, overall cell. Next. So this is a key parameter for especially for the amount of power it can be produced, and how efficient it is able to treat and utilize the given feedstock. So amount of power is directly related with the surface area of the anode and temperature and biofilm formation of anode, especially for microbial fuel cell. This is a key parameter. Like one is that how efficient we are going for surface area of anode, and temperature and biofilm formation on the anode, and then amount of power it can be produced. Next. So here we have done some of the work on the microbial fuel cell. So another like a fantastic work we have performed through our research students. And when you talk about this one, we have taken the cow manure, like a cow dung, and then sewage sludge. We taken this one, and we have developed our own microbial fuel cell setup. And then we used like we talk about the controller, and controller we use that. Of course, there is a software we use, the MATLAB program. So here the idea behind that we are mixed the cow dung manure and then sewage sludge proportionally, and then we are given into the anode. Then bacteria, the generation of bacteria slowly grow and increase the exchange of your electrons, and then we vary the ratio of your cow dung and sewage sludge. Especially we found that 2:1 and pH 6. Okay, and electrode depth approximately 7 centimeter. We got a highest current or power density like a 0.58 millivolts. Okay, and we have used our own controller. We design our controller through our laboratory one, and of course we are optimizing the different parameters which affecting the performance through the response surface response methodology through the Minitab software, and we got a nice result. And of course we used that kind of waste stream. So we also see the performance of chemical oxidant demand, that is COD. Almost 45% removal efficiency was there. So this is a fantastic, it's a good area, good work we are accumulated. Okay, next please. Next. So here some of the name of the microorganisms. I think the last slide. So these are all my. This is the microorganisms. Which last slide, please. Last slide. Next. Before. No. Before. No. Go for. Go back. Go back. But so you see here the microorganism mostly involved this one. This is the some of the microorganism. Go back another one. One more slide. No. Go back. One more. No, next. I think that's next. Okay, I think that slide is missed somewhere. Okay, so now the idea began that here also we can use the MFC microbial fuel cell. Now we can take as a feed instead of hydrogen, we go for the CO2 and microalgae. Okay, and then we can generate the power. Okay, electricity. So this is a fantastic nowadays novel research. People are working CO2 as a feedstock for microbial fuel cell. You see that these are all bacteria and fungi they are used for making these power productions with some of the biomethanation generation, bioethanol. These are all different microalgae. Okay, next. So these are all one of the work we have done. This is a tin oxide based photocatalysis we have used for hydrogen production, and then we got also good results. You see that we used for the tin oxides, and the mechanism is this one. Next. So that finally I should acknowledge my lab. These are all my labs are currently students are working in the green sustainable materials and biochemical bioengineering research laboratory and decarbonization and energy policy research laboratory and advanced analytical and simulation laboratory. So these are all labs which I am handling this one here. Next. So this is about our chemical engineering department. So our man at Bhopal, so we have two program: BTech Chemical Engineering, MTech Chemical Engineering, and PhD program as well. So these are all some of the state-of-art facilities are present in our department, and we have the Chemical Engineering Association as well as the student chapter as well as. Next. Right, these are all some of the research project ongoing there. So we have CO2 conversions. We have developing the clean air filters for making a clean air. We are developing the filter for by using the different low cost effective material, and then we are developing the biochar based material like to go for the energy storage application and carbon capture. And we are also developing the biodegradable polymer market means polymers. Okay, next. These are all some of the R&D project we are ongoing this one. So you see that Ministry of Mines and your Ministry of Textile, and this is some of the project for the air pollution. And here we are extracting the heavy metals, different precious metal, critical metals, and then here we developing the some nanomaterial for storing the CO2 and hydrogens, and then we use some of the air pollution for filter development, filter design of filters, different filter for sequencing the air pollutants. Next. So these are all some of the publication book publications. So we are publish this one. These are all is available in the internet source. You can see that it's like a industrial decarbonization, energy transitions. Okay, so then biorefinery in circular economics. Okay, so these are all some of the books. Next. These are all like already published the book, and this is a chemical engineering, energy material, biocomposite, and clean energies. These are all some of the books. Next. So thank you so much. and so I am finished myself. Okay, so please.
Does anyone have any questions?
Sir, may I have one question, please?
Yeah, please introduce yourself.
Yeah, sir.
So before introduce yourself, please.
Yeah, sir. Sir, I'm Ajit Kumar Gudekar. I'm PhD in chemical engineering, but now teaching in data science at DJ Sangvi College of Engineering, Vileparle, Mumbai.
So now you are doing project research work, research.
Little bit, not research like what you are doing, but yes, I have interest
Yeah,
in the
fine,
energy
fine,
domain.
fine, fine, fine. Yeah, tell me.
Yeah, I have interest in energy domain, so I had joined this FDP.
Mhm.
Okay, sir, what I wanted to ask is whether this technology, whatever you have done very good research in these fuel cells, and then you are trying for different resources as well, bioresources in particular. So, yeah, is it at a level where it can be commercialized, or still you are in development stage?
See, of course, what I'm saying that this proton exchange membrane is already commercialized. Okay, and
Yeah,
we talk about microbial fuel cell, and we talk about the phase change material. We are in the laboratory scale. We are doing for the TRL like a 3 to 4. Okay, so now we are looking for TRL like a technology go for the higher level.
right.
For example, in between the pilot scale and lab scale, we are planning to
Okay,
move. Okay, so we are working on that. Okay, so but you know, the using the nano fluid or phase change material as well as the this microbial fuel cell, it's almost like a micro, I can say that microbial fuel cell might be a commercialized little bit, but in phase change material and nano fluid, they are already commercialized in the
right, right.
exchange membrane. Okay, for the fuel cell, so it already commercialized.
Yes, sir. I was talking about the especially the cow dung process
Yeah,
that
yeah, that is.
you.
I told you that no, My thing is are in lab scale only, and we are
But
working
yes,
for
that will have
making things actually. Hmm.
because that sludge treatment is a huge problem all over the world and in India particular, and people are draining it in sea without any treatment or with some nominal treatment. So if
Correct.
this has some potential, then that will be the great
Very
thing.
correct. Very correct. So that's
Yes,
why
right.
we are trying our best, man. So see, everything should come forward, no, because we are
Yes,
working, we are putting our effort, and
yes,
very
yes.
soon, like we looking for like our
Industrial partners will be definitely
Yeah,
that will.
definitely. So, like, see, once upon time, we are in the in lower stage. Now we come up with some publication of our lab
Right.
scale work. Now we are looking for some higher scale, like going to the commercial one. So,
Right.
it takes some time. Okay, so we will certainly will do. We are working on that.
Great, sir. Thank
Mm.
you.
Yeah.
Maybe I will get in touch with you. I have noted down your
Anytime, most welcome,
details.
most welcome, most welcome.
Thank you. Thank you, sir. Thank you.
Does anyone have any questions? Any other question if you want to ask? I think, sir, everyone has been satisfied. So can we conclude here if you allow me to?
Yeah, sure, sure. Yeah, please, Yogendra Tyagi. Okay, yeah, please carry on.
Desh Deepak, sir.
Acha, Deepak, okay.
Desh Deepak.
Yes, Deepak. Because it's showing that there is some Yogendra Tyagi. I don't know.
He's been co-host of this
Yeah,
FD.
it's fine, fine. Please,
Yes, sir.
go forward.
Thank you. Thank you so much, everyone. Despite of your busy schedule, have been taken up this session, and also I would like to thanks on the behalf of our organizing committee to Professor Suresh sir for giving us their valuable time and sharing their valuable knowledge on different kinds of fuel cell technology, like microalgae, microbial fuel cell technology. I hope so that you all the participants get the valuable knowledge, valuable information about what are the core research area in the field of fuel cell technology. Thank you once again, sir, for joining this session and accept our proposal for this faculty development program. And
Sir,
also,
excuse
I would
me.
like to ask, yes, sir.
Sir, can I ask a small question, sir, with your
Yeah,
permission?
sure. Please, most welcome. Anytime. Yeah. I think
Sir,
if
thank
you
you,
are
sir.
if you are okay with your dinner time, I'm very happy to answer.
Thank you, sir. Thank you, sir.
Yeah.
My question is that, sir, biological waste material will be there, seeds which are not decomposing. They are containing carbon, hydrogen, and all other oxygen components will be there. From them can extract hydrogen, sir, by your microbial action, sir, please.
Yeah, definitely. See, you are talking about all the waste, no?
Yes, sir. Yes, sir. Please, sir.
All the waste. Okay. So yeah, of course, the also gee, that is the beauty of microbial fuel cell. Now, most of the place actually they are even gone for this. I can say that they gone for commercial one also. Like it is
Sir,
truly popular, and
sir.
you see that you mostly my thing is that all the waste we can whether you go for like a particular waste.
Sir,
Of course, you know the microbial activity of particular waste will be. I cannot say that least. It will be
sir,
like a some level. But when you are
sir,
mixing that two three waste or
sir,
liquid waste, so certainly there will be a chance of high intensive of or high activity of microbial growth. So when microbial growth is more higher, certainly there will be a electron transfer is more. So that's why my suggestion would be if you try for at least two
sir,
waste ratio combinedly or more
sir,
than
sir.
two waste, that will be better.
Thank you, sir. Thank you very much, sir.
Is there any further questions from anyone else? So let's sum up here this session. Now I would like to request to all the participants kindly switch on their cameras so that we can take a proper screenshot of this session along with our Professor S. Suresh sir.
Please, you can send to me also after.
Sure, sir.
I think I'm seeing that Dr. Preeti is there, Dr. Mallika Garchuna is there, Dr. Samuel C. Patel. So I think so many people are there. I
Yes,
think
sir.
participants.
Yes, sir.
Good number of participants.
More than 100 people are being joined in this.
Yeah, please have your photo, Anna. So maybe I am honored to make a photo with you. Please come forward.
So we are honored to have our photo
Yeah,
with
that
you.
is fine. But still, for the photo section, at least people can come over there. Okay. So we need to say something like that so that at least people can join. Yeah, participants, please have a photo with you. Please give the chance.
Yes, sir. We are so glad that you are such an eminent personality and you are the one of the 2% scientist of the world that has been recognized by Stanford University. We are so glad that we have taken a selfie and a screenshot along with you, sir.
Right. Thank you, man. So please.
Thank you so much, sir. Also, I would like to announce to all the participants that the feedback link has been shared up very soon in this session. So please be there so you can submit the feedback about this faculty development program session. Thank you once again as Suresh sir for joining this session. We are really so glad on the behalf of Sri Satya Sai University of Technology and Medical Sciences for giving your so much valuable time to all the participants also in this faculty development program. Thank you once again, sir.
Yeah, thank you so much. First of all, organizers and organizing team and administration of your Satya Sai, okay, universities and science and technology. Okay, wonderful. Have a time and all participants. Really, I'm so glad to see you guys. And maybe we can see at some other platform. Really, I'm happy to see you guys. Maybe more than 100 participants. Really great and wonderful. Have a good
Fine,
bit of
Chandrababu.
working and yeah, take a good dinner. Bye bye. Take care.
Thank you,
Yeah,
sir.
share me
Thank you
the
so much, sir.
series start, man. WhatsApp, share me. Should I go?
1 minute.
Thank you so much, everyone, for joining this session. And soon we will get into this Zoom work meeting with another resource person, that is Dr. Naren Kumar sir. Within 5 to 10 minutes, we are joining in this again. We will meet up again in this session. Also, I would like to highlight that the feedback link has been shared up in this chat section, so you can go through there and kindly submit your valuable feedback for this session. We are really thankful to all the participants for joining this session. Apart from despite being for your busy schedule, still you are being there in a good number. That's being making this faculty development program as a great success for us. Thank you. We will meet up within 5 to 10 minutes again.
Hello, am I audible?
Yes, sir, you are audible.
Okay, thank you. Sir, can you make me presenter so that I can check whether I am able to share my screen or not?
No, sir, not visible yet.
Not visible, sir.
No. Please make me presenter so that I can
Yes, sir.
share
Sure.
my.
Sure. Now is it okay, sir?
Let me check.
Yes, sir.
Mm,
Recording in progress.
Sir, still I'm not able to find the option where from
Sir,
it can be select.
actually, you should have to go to into the share section, sir, where you can.
No, I'm not able to see, share section here. I don't know why.
Let me check once again, sir. I will make you once again post. Host up. Sir, now is it visible?
Oh, still I'm not leave more. You see, I am able to find only options like participant, chat, reactions, security, AI companion, and
Sir,
more.
kindly rejoin the session once again, sir.
Okay, I will check. I will check. Thank you.
For the upcoming session, we have a Dr. Naren Kumar, sir. So I would like to request to all the participants kindly join the session. It's been going to start very short, within 5 to 10 minutes, very shortly.
बंदा कर दे रहा बेटा अभी आ जाएगा थोड़ी देर क्या मुझे भेजे सर आप अपनी पीपीटी मुझे व्हाट्सएप कर दीजिए यहाँ से
Sir, I'm going to share, okay? Just wait. Now
Now,
I've got the option.
now is it okay from your side, sir?
Yeah. No issue.
Sir, you are able to share the screen?
Just wait, sir.
Yes, sir.
I will- Sir, can you see my screen? Please confirm.
No, sir.
No? Okay. Share entire screen. Yes. Now I got the. No, I have got the option now. Now tell me.
Now, yes, sir. Now your
Okay.
slides has been visible.
Okay, sir. Thank you.
Okay, so good evening, everyone. Now we have a resource person for the
Mhm.
upcoming session number 10. That for this faculty development program, we have a respected guest, that is Dr. Naren Kumar sir, for taking this session for this FDP program, and we are hope so that their knowledge has to be shared up to all the participant, and we get a lot of things from Dr. Naren Kumar sir. For the Naren Kumar sir, I would like to introduce some brief introduction of Dr. Naren Kumar sir. He has been currently holds the position of assistant professor in the Department of Industrial and Production Engineering at Dr. B.R. Ambedkar National Institute of Technology, Jalandhar. He is a recipient of the prestigious IEI Younger Engineer Award by the Institution of Engineers India and the Best Teacher Award 2024 by NIT Jalandhar in recognition of his contribution to the field of production engineering with over 12 years of experience in both research and the teaching at undergraduate and postgraduate level. He has been established himself as an expert academician. He has also secured funding of 3.5 crore rupees pursuing research on 3D printing from DST, ISRO, BIS, and ANRF. Also, I would like to highlight about Dr. Naren sir that he has been impressive publication record with more than 60 research papers to his name. These research papers have been published in reputable international peer-reviewed journal as well as national and international conferences. Also, I would like to highlight that he has actively participated in various academic forums, serving as a resource person, delivering invited lecture and chairing scientific session in numerous national and international conferences. So guys, today we have a Dr. Naren Kumar sir. This is just a brief introduction about himself. So also we are so glad that Dr. Naren sir has been sharing their valuable time with us, and on the behalf of Sri Satya University of Technology and Medical Sciences (COR) and the organizing committee of this faculty development program, we welcome you, sir, and also welcome to all the participants has been joined up in this FDP session. Now over to you, sir. You can carry forward from there. Here.
Okay, so good evening, everyone. I hope I am audible to all of you. Hello,
Yes, sir.
I am
Yes, sir.
audible.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay. So thank you so much for. I am really thankful to the organizer for inviting me for this particular talk, and I congratulate the whole team for organizing such a wonderful FDP on the very good topic, that is green hydrogen and future renewable energy systems. So under this particular FDP, I have been asked to deliver a talk on the solar thermal systems, right?
Right.
So before I begin with my lecture, let me ask you a simple question. How many of you have seen a solar water heater on the rooftop? Have you seen? Have you seen
Yes.
Yes, sir.
this?
Yes, sir.
Yes.
It's working in our home.
Yes, at home, in the hostels, in the institute buildings, right?
Any applications, sir?
So we all know the application part of the solar thermal energy, right? So today, briefly, I will be discussing about this thing. So where we will see the uh, fundamentals of solar thermal systems. Then what is the history? Where means in which year actually this whole systems were started, right? So these things we will see in detail. So this is my presentation outline in which I will be talking about this solar thermal energy and history of this solar thermal energy, and then the classification of the solar energy systems, right? And solar radiation. Then after that, I have few case studies on which I have already worked on. So I would love to share those case studies with you all. So now my question is, what is solar thermal energy? So I will start with the fundamentals first, right? Because most of you might not be aware with these fundamentals also. So here I will be talking about fundamentals of solar thermal energy. So here, as you know, that solar thermal energy refers to the technology that captures solar radiation, right, and converts it directly into heat. So instead of converting this radiation into electricity, our focus basically generally is on the conversion of this solar radiation into heat, right? So this heat then be used for a wide range of applications. As I already given you an example of water heating on the rooftop, right? So we can use this heat to heat the water and for space heating purpose, right? Industrial process heat for cooking purpose, right? And for what power generation also. Okay. So unlike solar photovoltaic systems, which convert the sunlight into electricity, solar thermal systems focus on meeting heating requirements of the user, right? So basic principle of thermal energy is quite simple. Okay, like solar energy radiation is absorbed by a surface that is known as absorber, right? And where it is converted into heat. So then this heat is transferred to a working fluid. So fluid may be water, it may be air, it may be oil, and sometimes you may have also the molten salt. Okay. So this useful heat can either be used directly or it could be stored for the later use, or later on we can convert this heat into other form of energy also. Okay. So now the question is why the solar thermal energy is important. Why we are talking about the solar thermal systems? So very, the significant advantage of this particular energy is its high thermal efficiency, especially for the heating applications, which I have already talked about. So in most of the cases, this thermal systems can achieve efficiency up to 50 to 70%, which is much higher than the solar photovoltaic systems, right? And another key advantage is the ease of thermal energy storage, so which improves the reliability and usability. Okay. So the range of applications which could be the where we can use this solar thermal energy, there is wide temperature ranges are there. So we can use the solar thermal energy for low temperature systems, like for domestic water heating or the cooking food, medium temperature systems, right? That is required in the industrial process heat, and also high temperature systems where we can use the concentrated solar energy, okay, to generate the electricity also, right? So okay, so now the question again, why we are talking about this particular topic? Because countries like India, we have excellent potential for solar thermal energy, because in most of the states we have very good the radiation of this solar thermal energy. Okay, and we can install the collectors there, and we can easily harness this energy for the various applications. So now, what is the meaning of this solar radiation? Solar radiation, right? So solar radiation is the electromagnetic energy emitted by the sun and received on the Earth's surface, right? And it is the primary source of energy for all solar energy systems. So when sunlight reaches the Earth, it does not come in only one form, right? So basically, there are mainly two useful components of the solar thermal systems. One is the direct radiation, which comes straight from the sun, or it can be concentrated, right? Or it can be used, in the high temperature applications. However, if you look at the second component, that is the diffuse radiation. So this radiation is nothing but the radiation scattered by the cloud, dust, atmosphere, okay, and it cannot be concentrated. So that's why this kind of radiation is used in the flat plate or evacuated tube collectors. So that I will be discussing in the next slides, right? You might have seen, even a cloudy day, solar water heaters still work. Why? Although direct radiation is not available, but still we get, the some heat through this diffuse radiation, right? So even if cloudy day is there, still we can get some heated water. from the solar water heater. Okay. So this low temperature collectors that I will be talking about in the coming slides, it can use both direct and diffuse radiation. But if I talk about the concentrating systems, they are mainly depend on the direct radiation. Okay, because the temperature requirements are very high. Okay. Now the question is, because we have already discussed about the two components of the solar radiation. So now the question is how the clouds location or tilt affect the solar thermal performance. Okay. So as I have already highlighted few points regarding the this effect of cloud. So the presence of cloud affect the direct solar radiation. Okay, and it increases the diffuse radiation, which we have already talked about. So there are two types of radiation. One is the direct radiation, and second one is the diffuse radiation. So obviously, when the clouds are there, the direct radiation will be affected, and it will be converted into the diffuse radiation. Okay, so this is how the cloud may affect the performance of solar heaters, solar collector. Okay, obviously because it is going to affect the performance. So as I told you, flat plate or vacuated the tube collectors perform better than the concentrating system under the presence of diffuse radiation or under the effect of cloud. Okay. Second thing is the effect of location. Effect of location. So solar output also highly depends on the latitude and solar insolation. Okay. So where we have suppose the high uh, intensity of the solar radiation, where we can easily use the concentrating systems, or wherever we require the high temperature applications of the solar thermal energy, we can use the we can use the we can easily use the solar energy systems in the high intensity solar radiation, right? So second thing is the effect of tilt angle. So tilt angle, that tilt angle is very very important. How the solar radiation is falling on the the surface, that is also very very important point. Okay, so here what happens, because tilt angle controls how much radiation falls on the collector surface. So if we are maintaining this tilt angle, it will increase the annual energy collection also. Okay, because sun changes its position from morning to evening. So if you have a mechanism by which you can maintain the tilt angle of the surface, which is collecting radiation directly from the sun, so it can give you the good. It can give you better results or better performance, right? So a collector tilted properly toward the sun receives obviously more energy throughout the year. Okay. Then next is the heat absorption in solar thermal systems, right? So here you can see that the purpose of the solar collector, as I told you, we have to collect the radiation from the sun. So a solar collector is a simple surface that absorbs maximum solar energy and convert it into heat. Okay, so that you can see in this diagram also, right? And the top we have a transparent cover, and in between these covers we have the absorber plate. Okay, then we have this tube array. Okay, then when you can see in the tubes the fluid is entering. Okay, fluid in, and from the other side fluid is coming out, right? So here how this absorption happens. So solar radiation passes through the glass that is on the top, transparent cover is there. Then absorber, the absorb the heat and it converts light into the heat. Okay. Then heat is transferred to the fluid, and fluid, as I told you, it may be water or it may be oil. Okay. As you are aware with the fact that black surfaces absorb more radiation. So that is why the absorber plates are dark in color. Okay, that's why we design or we uh, develop this absorber plate with dark color. Okay, so this is how we absorb heat in solar thermal systems. Then we have uh, you know because 100% solar radiation cannot be absorbed by any kind of system. So obviously heat losses are involved, right, in the process also. So because not all absorbed heat is useful, some of it uh, is lost to the surroundings. So how this major heat loss mechanism takes place? So this heat loss is happened due to the conduction, due to convection, right, and due to radiation also. So conduction, if you look at this diagram, right, heat conduction is there, that is at the bottom side. It is lost due to conduction. Okay, so heat loss through the bottom and the side of this absorber, and so it can be reduced. If you want to reduce this particular loss, you can apply insulation properly, right? And as we do in the thermoplast bottles, okay, thermal bottles. So you can apply some sort of insulation there to improve the heat losses. Then convection is loss is uh, happen actually due to the heat carried away by the air movement, because whenever we will install these solar absorbers, okay, this heat absorption plates in the surrounding, obviously there may be air there. Okay, so it also depend on the movement of the air, right? So if we want to suppose reduce this particular loss, so we can install these things, or we can maintain some vacuum there, or we can apply some sort of coating or glazing, right? S- Radiation, when the heat radiated back to the sky, again it is reflected back or from the surface, right? So it can also be reduced by selective coatings. Okay, so whenever we design a solar thermal system, we always take care about these losses. So our design is mainly about reducing these losses. Okay, because once the heat is absorbed by the absorber plate, it should be converted into the heat. Otherwise, or it should be used, most of the portion should be used for some particular application. So if we maintain these losses, okay, toward the minimum side, obviously we can improve the efficiency. So what is the role of insulation? So as I told you, even you have a best absorber with you, that is useless if heat losses are there. Okay, or if heat escapes quickly in no time. So insulation may help you in reducing the conduction losses, right? Maintaining the higher temperature, improving the overall efficiency. Okay. So performance of the solar thermal systems, depends on the three things, I think. So how much radiation it receives, right? How well it absorbs the heat, and how effectively it prevents the heat losses, right? So I think these 3 points. That's why insulation, can help in these things, or can maintain the temperature also, or can improve the overall efficiency of this. So now let me share the history of solar thermal energy systems. So first system was invented, or I can say the introduced to the people, dates back more than 100 years. Okay. So in 1878, Augustine, Mousshot demonstrated a solar-powered ice cream making machine. Then later in 1907, Frank Suman, an American engineer, developed a small solar-powered engine. Right? And his work proved that solar thermal energy could be used to run mechanical systems, not just laboratory demonstrations. So he actually made a system in which he used this solar energy to run the mechanical systems that time, right? So the most significant milestone came during 1912 to 1913, when the Frank Soman built the world first solar thermal power station in Madi, Egypt. Okay, and why? To just pump water from the Nile River. So the the used engine in that particular case was solar power. So this was the first the breakthrough in the solar thermal energy system history. So this plant actually used the solar collectors to generate steam, and that steam was used to power the engines to pump water from the Nile River. Okay. So he simply used the solar heat to produce the steam and mechanical power. So today also we are using same principle in the modern concentrated solar power plants. Same thing we are doing, right? We are generating steam, then we are using steam to generate the electricity. Okay. So this idea of using the solar thermal system is not new. We are studying the same technology that has evolved over a century. Now it is supported by better materials, better designs, and improved engineering. So with time, actually, this particular area has been improved a lot. So here you can see the picture of that particular solar thermal power plant that was built in Egypt in 1912. So as I told you, this plant was used for irrigation purposes. Okay, and in this system, parabolic collectors were used to concentrate the sunlight onto the pipes carrying water. Okay, and the concentrated heat produced steam, which then drove the mechanical pumps. Okay. So with this historical foundation, let us now move on to the understand how this solar radiation is collected and converted into thermal energy in present day systems. Okay, so now we will move to the classification of solar thermal energy, major classifications. So according to the achievable temperature, The solar thermal energy, can be classified into three categories. First is these low temperature solar collectors. Then we have the second one, medium temperature solar collectors. Here the temperature range lies in between the 100 and 400 degrees centigrade, right? And third one is the high temperature solar collectors. So where you can have the range more than 400 degrees centigrade. So these collectors are used to convert the solar radiation into heat energy, right? And in every category we have different types of collectors that are used to generate heat energy for various applications. So I already have shared the range of temperature with you, right? So low temperature systems can be used for the purpose of water heating, space heating, drying and cooking purposes, right? And then medium temperature systems could be used in the industrial process heat, solar refrigeration systems, and steam generations. However, if I talk about the high temperature solar collectors, they could be used to generate electric power, right? Or other processes where the high temperature is required. So if I talk about the low temperature solar thermal systems, as I told you, they operate at temperature below 100 degrees Celsius, right? So these systems do not require solar concentration. They can utilize the both direct and diffuse solar radiation, right? So the common example under these categories are the flat plate collectors or the evacuated tube collectors, right? And similarly, the medium temperature solar systems. Here we can use technologies like parabolic neutron collectors and linear Fresnel reflectors as well, right? And their application I already discussed with you. So the temperature range which I have mentioned here, that is 100 to 400 degrees centigrade. So at this temperature range, solar tracking becomes necessary to maintain high efficiency. So that's why I talk about the tilt angle, right? So we have to maintain the tilt angle also, or we have to tilt the collector according to the sun position. Then only we can achieve this much temperature. Otherwise, it is not possible at all. Okay. And high temperature solar thermal systems, they operate at temperature, as I told you, above 400 degrees centigrade. So they rely entirely on the concentrated solar radiation. And they also require precise solar tracking because here temperature requirements are high. So examples like, the uh, solar power tower systems, parabolic base systems, right? So these systems can be uh, uh, are the example of the high temperature solar collectors. Okay. So now let's move to the low temperature solar collectors. So we will discuss about these collectors in detail. So as I told you, low temperature collector use the non concentrated light, right? And they typically operate at the temperature below 100 degrees Celsius and do not require solar concentration. Okay. So these collectors are capable of utilizing both direct and diffuse solar radiation. So which makes them effective even under partially cloudy conditions. So even though if cloudy conditions are there, still because it uses these diffuse solar radiation. Okay, as you have seen in the case of the solar water geyser, right? Solar heater geyser. So in that case, even we have a cloudy conditions. In that case also, these kind of systems, like, may provide you the hot water. Okay. So applications already I have discussed: domestic water heating, space heating, this swimming pool heating also. So let us now look more closely at one of the most widely used solar thermal device, that is solar flat plate collector, right? So it is, under, it comes under the, the category of low temperature solar collector. Okay. So as I told you, it is the non-concentrating type stationary solar collector, and it is designed to absorb the solar radiation and convert it into the useful thermal energy. So if I talk about its construction, right? Construction, it has mainly it has four main components. First one is the transparent glass cover, right, which allows the solar radiation to enter while reducing the heat losses. Okay. Second thing is the blackened absorber plate, usually made of copper or aluminum. Okay, which absorb the solar radiation and convert it into heat. So second, important component is the absorber plate, that is, generally made of black color. Third, I would say a network or channels made of tubes, right, which are attached to the absorber plates. So we have a glass cover, then we have a absorber plate, then we have the tube or channel which are connected to the absorber plate, and through which the working fluid, usually the water flows, right? And finally, the fourth component is the thermal insulation. So that is provided at the back side of the uh, collector, right, to minimize the heat losses. Because from the top, we are receiving solar radiation, right? So we cannot apply insulation there. But on the back side, because already we have absorbed heat, so to avoid the or to minimize the heat losses, we can apply thermal insulation there, right? So simple, it has very simple working principle. When sunlight falls on the collector, it passes through the glass cover and strike the absorber plate, right? And after that, the absorber plate heats up and transfer this heat to the fluid flowing through the tubes, right? And then heated fluid flows to a storage tank where the thermal energy is stored for the later use, right? So this circulation may occur naturally due to the thermo siphon action, or maybe water may be driven by a pump. It depends on the application part, right? So heat losses, are not that much, high. We can, because we can reduce the convective or radiative losses by using this glass cover, right? Because we already use insulation there, which reduces the conductive loss also. And sometimes we can apply, coatings on the absorber plate further to just improve the performance, right, by increasing the solar absorption, reduce heat emissions. So here you can see some of the images of the solar flat plate collectors. Second type of collector under this category is the solar evacuated tube collector. So it is also known as ETC, evacuated tube collectors, right? ETC. So these are designed to achieve the higher efficiency by reducing the heat losses. Okay. And they are the non-concentrating solar thermal collector. But if you talk about their performance, they perform better than the flat plate collectors, especially in the cold and windy conditions. Because I told you, in the windy or cold conditions, the flat plate collectors may have, the high losses, right? So these collectors actually operates up to the 120 or 150 degree centigrade temperature, depending on the their designs and operating conditions. So if I talk about their construction, this collector consists of a series of cylindrical glass tubes. So these are the glass tubes that you can see in this picture also. Okay, in the image you can see we have some glass tubes. They are arranged in the parallel manner. So all tubes are parallel. Okay, and each tube has two layer of glass with vacuum between them. Because why vacuum? Because vacuum acts as a excellent insulation and it eliminates the convective and conductive heat losses. So inside the tube, heat is absorbed either by selectively coated absorb surface or by a heat pipe. Okay. So working principle is quite similar to the previous one. And the losses are significantly lower than the flat plate collector. So as a result, they maintain the higher efficiency even at low ambient temperatures or during winter months. And they also perform better under the diffuse radiation conditions. So diffuse radiation condition means cloudy days when we have the diffuse radiation a lot in the environment. Because direct radiation sometimes is not present due to the presence of the cloud. Okay, so in that case, these collectors can give us the solution. So applications maybe in the domestic water heating, hot water supply in hotels, hospitals, hostels, right? Or other institution applications. Okay. But if I talk about the cost of these collectors as compared to the flat plate, these are costly. Okay. This is one of the disadvantage or limitation. And one more thing, because we use glass tubes here, they are more fragile as compared to the uh, previous one, and it requires the careful handling of the tubes. Otherwise, there may be problem with the components of this collector. Solar air heater. So here, in all the previous in the previous two cases, we have seen that so liquid such as water, was working, was using as a working fluid, right? But here, because the name is the solar air heater, so here we most of the time, or not most of the time, every time we use air as a working fluid, right? That's why it is known as solar air heater. So in this type of heater, air itself act as a heat transfer medium instead of water or oil. Okay. So basic construction, it has a transparent glass cover and a dark absorber plate and very important airflow channel, right? And insulation at the back end side. So radiation enter through the glass cover, absorbed by the absorber plate, which heats up, right? And the air flowing through the channels comes in the contact with the hot absorber surface and it gains heat. Sorry. So working principle is like cool air enters the collector either naturally or using a blower. Okay. So as the air passes over or under the absorber plate, it absorbs heat and exit as a hot air. This is very simple principle. And the application could be in the space heating purposes, drying purposes, ventilation purposes. So these are some of the applications. We can have also single pass air heaters, double pass air heaters. Depends on the requirement and the design, right? Next category or uh, classification is the medium temperature solar collectors. So after discussing the low temperature solar collector, let us now move to the medium temperature solar collectors, which are widely used in industrial heating processes. Okay. And their range in which they operate, that is the 100 to 400 degrees centigrade. So as we have seen in the previous cases, at these temperature level, the previous collectors are no longer sufficient, right? So solar energy must be concentrated to achieve this much higher temperature, right? So here there is a need for solar concentration. So how can we concentrate solar radiation? By using the reflective surfaces, right? So concentration increases the intensity of solar radiation falling on the absorber. Obviously, there will be observer, but here we will use the concentrated energy or radiation to use these kind of collectors for high temperature heating applications, right? And here also solar tracking is essential, right? So every time the face of the observer plate should be toward the sun. Okay. Now we have the application part of the medium temperature solar collectors. So it is in the solar cooker or box or flat plate type. So there are two types of actually solar cookers. First one is the this flat plate type. Second is the parabolic type. So as you can see in this picture, this is very simplest and most familiar application of solar thermal energy. So this image is related to the solar cooker, particularly the box or flat plate type solar cooker. So it has very basic principles as we have seen in the case of flat plate solar collector. But here instead of the heating water, we use this for cooking food. So construction is quite similar to the flat plate collector, right? Here we have a cooking surface, that is the absorber plate, right? And we have a reflective mirror also here that is attached to the lid to direct additional sunlight into the box, right? And we also have an insulated box that is made of metal or wood sometime. Okay. And inside balls are usually painted black with reflective materials to enhance the absorption capacity. So slow cooking, boiling, steaming, and water pasteurization, we can use this kind of cooker. Then we have solar cooker, parabolic type. So this is the more advanced and powerful designed solar cooker. So this parabolic solar cooker works on the principle of solar concentration, right? Solar concentration, and this solar concentration allows it to achieve the much higher temperature. So you can see it's safe, right? It has the parabolic disc. Okay. So at the focus of the parabola, a cooking vessel or receiver is placed. So that's why you can see we have placed a receiver there. Okay. And around its surrounding we have the uh, parabolic disc, which is collecting the solar radiation and focusing it toward the receiver. So in which you can cook the food at much higher temperature, that is around 200 to 300 degrees Celsius. Okay, and in some designs maybe the temperature may be even higher, right? So you can use this solar cooker for frying, roasting, and boiling purposes, similar to the conventional gas stoves. Okay. So under the cloudy conditions, as I told you, under the cloudy conditions, uh, the performance drops significantly because there is no direct sunlight or very less intensity radiation is available. So that's why these cookers are not suitable for these conditions. The next type is the high temperature solar collectors, right? So high temperature solar collectors, they operates above 400 degree, or 500 degree centigrades. In some cases, it can reach up to 800 degrees Celsius also, right? At such high temperatures, solar concentration and precise tracking is essential, right? And application of these kind of collectors are in the electricity generation and high temperature heating applications. Okay, because these collectors can concentrate a large amount of solar radiation on a small receiver area. So as a result, it can significantly increase the temperature of the receiver. Okay, so different types of receivers or collectors are there. First one is the solar parabolic trough collector, or disk collector, you can call it. Solar power tower is there, and we can have the some other types also. So here I will be discussing about the parabolic trough collector or disk collector, right? So parabolic trough collectors are the line focusing solar thermal systems, right? They are designed to produce medium to high temperature heat, that is around the 250 to 400 degrees Celsius, okay, or nearly 400 degrees Celsius. So this parabolic collector consists of a parabolic shaped reflective mirror, as you have seen in the previous case, right? We have a parabolic disc which has the reflective mirror there that focuses incoming sunlight onto a receiver tube. So we will have a receiver tube, and we will have a parabolic shaped reflective mirror, right there, and the receiver tube is placed along the focal line of the parabol. Okay, so this receiver tube is usually made of metal, and it is enclosed within a transparent glass envelope. Okay, similar to the previously discussed collectors, we will have a glass envelope, and we will have a receiver tube that will capture all the radiation which is coming toward it. So inside the receiver tube, flows a heat transfer fluid that can be synthetic oil or the molten salt, right? Because at such a high temperature, these two fluids may survive. Okay, so when the sunlight falls on this parabolic mirror, it is reflected and concentrated onto the receiver tube. So the concentrated solar radiation heats the fluid flowing through the receiver tube to high temperature. Okay, and the hot fluid is then transported to the heat exchanger, where the thermal energy is used to produce steam or supply industrial process heat. This is how these collectors works, right? So to enable the solar tracking, we can use the single axis solar tracking system, which can follow the sun from east to west, right? So accurate tracking is essential in these cases to maintain the focus on the receiver tube. then only this much high temperature can be achieved, right? So this here you can see another type of high temperature solar collector. So this the solar disk Stirling system. It is a point focusing or high temperature solar collector, right? It is it also uses the parabolic disk reflector, as we have seen in the previous case, to concentrate the sunlight onto the receiver located at the focal point of the disk. Because of high concentration, very high temperature can be achieved. That may be up to 800 degrees centigrade also. Okay. So main components of the solar disk Stirling system include a parabolic disk reflector, and we have a receiver. Okay, and we have a Stirling engine coupled with an electric generator. That's why this is known as solar disk Stirling, right? And disk is mounted on a dual axis tracking system. So it allows it to continuously face the sun throughout the day, right? So this is the picture of the solar power tower. Okay, so here we have a central receiver, we have a heat transfer fluid system, we have a thermal energy storage unit, right? And we have a power block here consisting of a steam turbine or generator, right? And here receiver absorb the concentrated solar energy and transfer it to the working fluid. That is most of the time it is molten salt, right? So when the sunlight is concentrated here and on the tower, right? It is reflected back by thousands of heliostat, and it is concentrated onto the receivers which are installed around its region, okay, or its surrounding, which heats the molten salt to very high temperature, right? So whenever electricity is required, the storage heat is used to generate steam. So which drives a turbine to produce electricity. This is not the photovoltaic cell. This is the uh, application of the steam generation through the solar power. Okay, so solar power tower can help in generating that steam, and we can run turbine easily, right? And we can produce electricity by using this steam, generated steam. So solar power tower systems achieve higher operating temperature than the other type of collectors, right? So resulting it provides better efficiency as compared to the previous one, right? So they usually operate in between the 500 to 1000 degree centigrade. Another type under this category is the solar parabolic disk collector. So as already we have seen the application of parabolic disk collector in the previous cases. So it also uses a disk shaped reflective surface that concentrate incoming sunlight onto a small receiver that is placed on the focal point of this parabolic disk. So because all the reflected rays meet at a single point, right? Extremely high temperature can be achieved. Okay, with the help of this type of collector. Then we have a solar power plant, right? So we have already seen the application of the solar power into the electricity generation using the solar tower, right? So same principle actually is used here. Okay, and here we receive solar energy, and this is to produce heat. Then heat is used to generate a steam, and which drives a turbine connected to the electrical generator. Right. So this is very simple. So that you can see here also in this image, the sun is there, and we have a a heliostat field. Center receiver is there, on which the whole this radiation is focused. Okay, and then steam is going toward the this receiver, and from receiver it is collecting heat. Then steam is produced. Then steam is coming back toward the turbines. So turbines are there. Turbines are rotating, and then after this rotation, we are receiving the electricity that is transmitted to the various uh, places, right? So if I compare, the different concentrated solar power technologies, here you can see the clear difference, right? You can see the difference in the operating temperature, and you can also see the difference in the solar concentration. In the first case, it is medium. In the second case, it is high. In the third case, it is very high, right? And efficiency is also very good in the third case. Okay. So my team has also worked in this area, because my area is 3D printing. So I usually explore various applications to 3D printing. So one of my research scholar, right, he explored this area by developing the heat exchangers using 3D printing. So what we did, we made the heat exchangers using these additive manufacturing processes, right? And what was the purpose? With the objective to improve the efficiency of solar parabolic disk collector system, right? So here what we did, we selected the some material initially, just to check the design, whether we can print the design, whatever design we selected for the heat exchanger, whether we could print it or not. So initially we selected some sort of process parameter, right? So you can see here I have given the various images, in which you can see the orientation, slice data, right, and different parameters which were used to fabricate the heat exchanger, right? So here I have mentioned the stages which were used to fabricate the thermo this heat exchanger, right, additive manufacturing heat exchanger, and the pure TPU. So initially we took two materials, right? Two materials. One was TPU, and second one was the polymer composite, right? Polymer composite, thermally conductive polymer composite, additive manufactured heat exchanger, and second one was the pure TPU, right? Because we wanted to make the flexible kind of heat exchanger for some applications, right? So after fabrication, we install those heat exchangers in the receiver, right? Because as a receiver we have used that particular heat exchanger here. So here we have a parabolic disc collector, then we have a receiver at the center point that you can see, right? And at the bottom you can see two buckets. One bucket is basically has the the cold water, and on the on the other side we have a bucket which is collecting the hot water. So we just check the temperature of the water on the both side to just see the efficiency of the heat exchanger which we have developed, right, in our case. So here I would show you the arrangements, how we have installed the heat exchanger that we have printed through the the heat additive manufacturing, right? So you can see that this is the receiver, and how we have how we placed the additively manufactured heat exchanger on this receiver. So that could be seen here. Okay, this white one is the heat exchanger which we have printed so far. So this is the schematic, representation of the, the receiver and the parabolic dish, right? And how we have, supplied the water through this heat exchanger, and on the other side we collected the water and we checked its temperature, right, by using the thermometers, right? And as a result of this, we compare the results of our study with the previous studies. So in our study, we found that our heat exchanger uh, were having very good efficiency, showed very good results, and you can see that our study, present study, that is indicated by the red point. Okay, so it has the high efficiency as compared to the previous one. So we got approximately 73.49 percentage, right, thermal efficiency with the modified hemispherical type heat exchanger, right? So this is, I think, the one of the very good study based on this. And if I talk about concluded remarks of this particular study, so here for thermal efficiency, copper coil indicates a magnitude of 29.46 for the roll number 1453. However, for the same round number, the arrangements of the copper coil with pure TPU, that the heat exchanger which we have printed using additive manufacturing, the magnitude of thermal efficiency was increased up to the 33.43 percentage and 38.91%. Okay, for TCPC, thermally conductive polymer composite. And the highest efficiency we obtained for the arrangements of the copper coil with thermally conductive polymer composites additively manufactured, this heat exchanger at row number 7314. So which, illustrate the significant impact and potential of this study, right? Uh, and it could be used also in the future investigations, right? And currently we are also working, on one of the projects. Here we are trying to use the multiple disease, right? And we want to study their results, how we can collect more full solar radiation, right? Or with the single receiver, how can we concentrate sunlight onto the single receiver by just using the multiple disease? So I will not talk about much about this study, right? This is a experimented methodology which we are using currently, right? We have also used some sort of electronics and data acquisition systems to collect data, right? Real-time data of the temperature, right? And we have, found very good results with this. Okay, so here we have compared the thermal efficiency with single dish and the thermal efficiency with multi-dish. Okay, so here we have, obtained very good results. So here now I conclude, my lecture. So if you have any, the query or any, doubt or any suggestion, you are most welcome to ask. Thank you. So it is all from my side. Thank you, everyone. Hello.
Is there any questions from any one of your participants?
Hello, sir.
Yes, yes.
Sir, have you tried the vacuum receivers as well for your systems?
Sorry, pardon?
Vacuum receivers.
No, no, we have not used vacuum receiver.
Okay, okay, sir.
Hmm.
ठीक है सर.
You can explore this area because we try to print the polymer composite heat exchangers, okay, for very low temperature applications. So you can also explore this area. This is very new area, right? Here you can
Right.
also make flexible heat exchangers, flexible pipes. You can use them into the displays. So a lot of applications areas there. You can also use them in laptops, computers, right?
Right.
Is there any query now?
Is
Now
there
query
anyone? Anyone have any questions? I think we should have to conclude this session. Sir, if you allow me to, can we conclude this session?
Yeah, please, please.
Thank you so much, sir, for sharing your valuable thoughts and very valuable experience to all the participants in this FTP program. And also, I would like to thanks to all the participants who've been continuously being up in this Zoom Meet app through this FDP sessions. Also, on the behalf of Sri Satya Sai University of Technology and Medical Sciences, I would like to thanks to you, Dr. Naren Kumar, sir, for
Thank you, sir.
sharing
Thank you so much.
valuable insight and valuable information to all the participants. I hope so that this information and research areas has been implemented in a future by any one of our participants has been added up in this FDP program. And I think so that this information has been so much useful to all the participant has been participated in this faculty development program. Once again, I would like to thanks to all the participants. Now, I would like to request to all the participants, kindly switch on your camera so that we can take a proper screenshot of this session. Also, we have a nice screenshot with Dr. Naren Kumar sir.
स्क्रीन उपयोग करो मत कैमरा ऑन करोगे
Is it fine?
Yes, sir. Thank you, everyone. Also, I would like to say that the feedback link has been shared up into the comment section. You would go to there and check it out. The comment of feedback session for this session. Also, we are also expecting your any further improvement or any comments from your side so that we can further, if in case of future, we can improve in our faculty development program. It's being late night. Also, I would like to thanks to all the participants on behalf of Sri Satya University of Technology and Medical Sciences for giving your valuable time to this faculty development program. Continuously, there have been more than 50 plus 86 participants have been there in this Zoom Meet app. And also, I would like to thanks to our resource person for today's session, Dr. Naren Kumar sir. I think so that the solar thermal and various technologies and research areas has been shared up by Dr. Naren sir. And I hope so these key topics has been implemented up into the future research areas by all of the participants. Thank you once again to all the participants. Also, at last, from the organizing committee of this FDP program, I would like to
Thank you so
thank
much,
Dr.
sir.
Naren Kumar sir. Also, I would like to thanks to Dr. Sachin Baraskar sir, the chief coordinator of this faculty development program, and also the co-coordinator of this program, Mr. Manoj Kumar Ganwani sir. And at last, last but not the least, Dr. Mohit Gangwar sir, the research director. of Sri Satya University of Technology and Medical Sciences. And also I would like to thanks to Dr. Santosh Kumar Rai sir, who has been working up very hard for making this faculty development program very successful. Also, I would like to highlight that tomorrow will be the last session of this faculty development program. And tomorrow also we have conducted the 3 sessions for this FDP sessions. And also after the completion of these FDP sessions, we have organizing a test. So those participants have scoring more than 65, yes, 70% questions right, then they will issued a certificate. Also, one more thing, that 80% attendance is mandatory in this FDP program. So I would like to also request to all the participants, those who have missed out the FDP session for today might be joined for the upcoming tomorrow's session. So that's it from my side. Now I'm been signing off. Thanks to everyone for joining this session. Also,
Thank you so much, sir. Good night.
sorry, ma'am.
Sir,
Thank
feedback
you so
link.
much, sir.
Okay. Feedback link has been shared up in this
Sir,
chat
may I leave
section.
now?
No, sir, we can't see the feedback link.
Okay. Wait.
Sir,
I
may I
once,
leave now? You may continue. Hello.
yes, sir.
Sir, may I leave now or you may continue?
Yes, sir. You may leave, sir. Yes, sir. Thank you so much, sir, for giving your time.
Thank you.
मेरी पॉकेट मनी है लेकिन दौर चल रहा है फिलहाल इस तेरी पॉकेट मनी टीम का 115 पे 3 हार्दिक पंड्या
Sir, if possible, provide some PPTs for the examination.
Sure. We will try to provide.
Sir, if possible, provide some PPTs for the final examination.
Sure, sir.
Sir, what will be the
Because
probability?
certificate is totally based on the qualifying in the exam.
Sir, please speak slowly. Your voice has been echoing, sir.
Sir, actually, certificate is totally depending on the assessment, final test.
Also, the
So,
final
it
assessment
provides some.
plus 80% attendance is mandatory. I also highlighted in the first day of this FDP
Right, but
that 80% attendance
right,
is
but
mandatory.
provide some
That's why I'm
PPTs.
always try to say that those participants are being present in this FDP session has been marked up as a presentee in this FDP program. So if you missed out one of or any sessions, kindly join tomorrow's session, because tomorrow's session will be the last session and last day of this FDP program. After that completion of this FDP program, a Atal AICT certificate has been generated tomorrow after completion and submitted your test. Also, tomorrow there will be the program has been issued by the organizing committee that tomorrow's session has been started from 2 p.m. sharp. Is that clear?
Yes, sir.
Yes, sir. So,
Sir, please put these instructions in the WhatsApp group, because only 59 participants are right now there. So some people might have may missed out that. And also please let us know what type of questions, or it will be MCQ type or other questions.
yes, sir. I also want to highlight that the tomorrow session, the test has been conducted in a multiple choice form, and about 50 questions being there into the session, into the test, and all the timing of the test will be the 1 hour.
Sir, the mode of exam test should be either maybe Google Form or maybe Atal portal.
On the AICT Atal portal, sir.
Sir, I was facing certain problem during my last
ask
FDP.
one question at a time. Please, I request to
Yes.
every participant, ask one question at a time, please, so that we can answer up every questions. Now say, sir, Amir sir.
Sir, I share my recent feedback. When I was appeared in Atal portal examination, the portal is supposed to be might be struck at some of the time. Many time they can back out the candidate, those who are appear in the side. So for a safer side, I suggested you maybe depend upon your side. Part B or plan B should be appropriate, either maybe Google form, if maybe practically applicable for you.
Sure, sir. We will think about it, sir.
So, yes, sir.
We will convey
Thank
your
you.
message to the organizing committee of the FDP program so that we can think about your suggestion, whatever you are giving to us. Thank you, sir.
Thank you very much.
Any other questions?
Yes, sir.
FDP?
I was asking about at what time the exam will start.
Sir, after tomorrow, 2 o'clock, we will conducting a session number 11. And after completion of all the session, we have been at last of the sessions, we have been conducting a test. So we will let you know into the WhatsApp group also, so that you can properly attend the session of the test. Okay. Is that okay?
Yes, sir.
Okay, we will let you know into the WhatsApp group also, so that the test has been conducted smoothly from our side or also from your side.
Okay, sir. Thank you, sir. Thank you so much.
But tomorrow is a mandatory to all the participants. Kindly
Yes,
join the session. Don't miss out this opportunity. If you don't attend the session for tomorrow, you might be absent and your certificate can't be generated, and we can't be help you out for this session. For the
Hello,
generation
Desh sir.
for the generation of certificate.
Hello, Desh sir.
Yes, sir.
Arif here, sir.
Say, sir.
Sir, tomorrow any like timing will be evening only or in the afternoon you're planning this?
Sir, tomorrow we will conducting 3 sessions, and our
Okay.
session is going to start from 2 o'clock, 2 p.m.
Oh, okay, okay.
2 p.m. to might be 8 o'clock. We will sum up this session till 8 o'clock. So we will let you know the when we are conducting first session, then second session, then third session, and after completion of 3 sessions, we have been planned to
Because
conducting
in
an
our
online
institute,
test, sir.
exam is going on and like 2 p.m. will be difficult. Sir.
Okay, so you will let me know then what is
Um,
the criteria from your side. Okay.
Okay, okay.
Any further questions from any
No, sir. No.
participants? Any further questions?
No, no, sir. Thank you.
No, sir. Thank you.
So we can conclude it here. Say. Okay, so can we sum up the session here?
Sure, sir. Sure.
Okay, so thank you so much all the participants who's been joining despite your busy schedule, and you've been here continuously for this session. All the let me mute to okay, so let me conclude this session here, and I would like to expect that feedback form has been shared up in the Zoom Meet chat section. You just go through there and kindly submit your feedback so that we properly take your attendance from in our side. Okay, so I expecting that you will submit your feedback to about this session. Also, the all of the instruction like for the tomorrow session we will upload or we will let you know into the WhatsApp group. So thank you everyone for giving your valuable time for this FDP session and make this faculty development program as a grand successful from our side. Thank you everyone. Now let's sum up this session.
Thank you, sir.
Your host Desh Deepak Srivas has been signing off. Tomorrow we will meet up sharply at 2 o'clock. Good night to everyone. Thank you so much.
Good night, sir.
सर लिंक भेज दीजिए
Link has been shared up in the chat section. You just go through there.
सर कुछ प्रॉब्लम आ रहा है चैट सेक्शन में एक बार फिर भेज दीजिए प्लीज
Sure.
थैंक यू सर